In this video, I'm just going to cover some of the very basic concepts of how to work with arrays. It's not going to get into a lot of depth because that's kind of beyond what we can cover in this format, and you have the textbook to give you all the details, but just to talk through how an array might work. So the first thing to understand is how we can visualize what an array might look like, and typically programmers will draw a little chart that looks something like this to represent this idea that an array, unlike a variable, an array has multiple places where it can store information. And so if we have a line of code that says that we're going to create an integer array, or an array of integers of size 5, then we can visualize it with 5 blocks put together. The same picture could represent any data type. An array of any data type will look the same, or we can think of it as looking the same. So an array of strings would look something like that. In this video, I'm speaking to people who are Java programmers and C# programmers. So note that in some cases there are some minor differences. Java programmers would use a capital S there, and C# programmers typically use lowercase. So this visualization has 1, 2, 3, 4, 5, 6, 7 elements or slots, and so when you declare your array, you specify that in the square brackets. So we refer to that as the size of the array, or the length of the array. You can think of it as the number of positions or the number of containers in the array, and it's essentially unlimited size. I mean, there is a limit to it, but for practical purposes and the kind of work that we're doing at this stage, you can make the number as big as you need to make it. And again, the data type doesn't matter, so if we wanted to keep track of integers, we can just put int instead of decimal. And by the way, decimal would be like a double for Java programmers, but if we put int, then this is going to be an array of 7 elements that are all integers. Now when we declare, let's go back to this this length 5 array, or size 5 array of integers that we'll call numbers, and when we visualize that and we know that there are going to be 5 numbers that we can store in this, programmers have to have a way to refer to those individual spots in the array, or the individual, what we call the individual elements of the array. And so each one is numbered, just like the houses on your street are all numbered with a unique address, right? So in most programming languages, we start at 0, and then we go up until we have all the elements identified. And this is a really important concept, and it's really easy for beginning programmers to confuse when they start working. The length of my array is 5, but if we start at 0, that means the highest possible index we can have is 5 minus 1. Okay? In our daily lives, we typically start numbering at 1, so we're used to this idea that the last one would be number 5, and so we have to be careful about that, because that's a big cause of errors in our programs. So typically the way you want to think of it is that your arrays are always going to be, these are called index numbers, by the way, and your arrays are always going to be indexed starting at 0 and ending at whatever the length is minus 1. All right, so in our array of 7, you can take a second and mentally guess here while I'm pausing. What is the lowest index and what is the highest index? Our lowest index is always going to be 0, and our highest index is always going to be whatever our length is minus 1. So an array of 7 elements goes from 0 to 6 in terms of indexes. When we first create our array, when we have one of these lines of code that declares an array for us, the array is going to be filled with default values. And so if it's a numeric data type like an int, then these are all going to be filled with zeros by default. If they're decimals, they're going to be filled with 0.0, or doubles, same thing, 0.0. If it's filled with some type of reference data type, like a string, then it's going to be filled with null pointers. It's not going to be filled with empty strings, and that's an important thing to remember. But in any case, after we have created our array, the next thing we'll want to do with it is put something meaningful in it so that it's not just those default values. And so when we're working with an array, the array name itself, in this case I've created an array of doubles. We're calling it scores, and you can see that it's been initialized with 0.0. The identifier scores refers to the entire set of data, the entire array. So if I want to work with an individual spot within that, I have to use this bracket notation, and I have to refer to the index that I want. So if I write a line of code that says scores index 5 equals 5.6, then at runtime it's going to go to element 5, and it's going to assign that value 5.6. So it's just an assignment statement, the same as any other assignment statement. We just have to remember that unlike our primitive or simple data types we've been using up until now, we have to include that index number. And again, we'll use the analogy of an address where we can have a street name that refers to the entire street, but if we want to pick out an individual building, we have to specify an address. And so it's the same idea. And to continue with another example, this line of code is going to go to element 7, the element at index 7, and assign the value of 1.3. So assigning values is pretty straightforward. We just have to get the hang of using that index notation. Likewise, if we want to retrieve a value or read a value from the array, it's going to work the same way. If I want to add up those two numbers that I put in, I can, just like I refer to simple data types before, like an int or a double, I can refer to it. I just have to remember to put that index number. So this code is going to look at what's in index 5, and it's going to add it to whatever is in index 7, and it's going to assign that answer to the variable sum. And so that would be the equivalent of saying sum equals 6.9. Now, if you have a big array, that's a lot of assignment statements to go through and put values in each of those different elements. We've been using examples here of 5 or 10 elements. What if you had an array of 1,000 numbers, and you want to put a value in each one? That's a lot of assignment statements. And so as you develop more as programmers, you'll learn some tricks. You can do things like read them out of a file. You can create a loop that'll go through and populate the array and some things like that. But there is one fairly simple trick you can use if you know what the values need to be, and it's called an initializer list. And so an initializer list has to be done when you first declare the array. You can't do this later on. So the line of code where I create the array, in this case I'm making an array of integers called nums, I can use this curly brace notation to list all the numbers that I want to put in there. Notice that at runtime, C# or Java, this works in both languages, will figure out, it will count up how many numbers, how many ints you have given it, so you don't have to specify that here, which is useful because you may go back later and say, oh, I need one more number, and you don't have to remember then to go back and change the length. So it will figure out the length for you. And as it says here on the screen, this initializer code is essentially the same as all of this code at the bottom. It saves you from doing the assignment statements. And so you still, with an initializer list, you still have to type them all, but you can just list them with commas rather than having to write a bunch of individual statements. So it is one simple way that we can save a little bit of time. And again, as you get the hang of arrays, you'll pick up some other tricks you can do as well. once we have some data into our array, the whole point is that we want to be able to work with this data now and do something useful with it. So one of the very common tasks that programmers find themselves doing is what we refer to as an array traversal. And a traversal, or traversing an array, just means that we're going to go to every element in the array and process it somehow. And that could just be outputting it. It could be doing some math on it. It could be alphabetizing it if it's strings or something like that. So traversing is just a generic term for this process of going through and looking at each element and processing it. So the syntax for that is going to be pretty much the same every time you do a traversal. So this loop code that we're going to use is really useful, and it's something that you should memorize. You should, something you'll use often enough that you need to know it. So we've got this same array that we were just looking at. It's an array of ints with these 4 values in it. And so we can use a for loop to do a real simple traversal. And when I show this code, again, I'm speaking to 2 different audiences here. I have students learning Java and students learning C#, so I had to have some way of indicating that. So if you are a Java programmer, you would have this line of code. And if you are a C# programmer, you would have the second line of code. And there's also a difference in the length variable here, where in C# that would be a capital L. So anyway, the basic idea here is we have a for loop. We want to start it at 0. We want to stop it at notice this line of code here, this little section of code. We're stopping 1 less than the length because we said I is less than, not less than or equal to. So this is actually stopping at 1 less than length. And there are programmers who prefer, for clarity, to put less than or equal to, and then they put length -1. Either way is acceptable. It does obviously the exact same thing. And at the end of every iteration of the loop, we're going to add 1 to I. And so what this loop does, the code that we've got up here, is this just goes through and it prints out every element in the array. So it's going to print 4, and then the loop is going to iterate. We're going to add 1 to I, and now we're going to print out 6, and then 2, and then 7. And so that's just a real simple traversal where we're going to output whatever is in the array. All right. So the part that we want you to learn and get the hang of is this loop. And how do we write the loop? It should be something you should be able to do from memory, because you should do it often enough that you get the hang of it. Now, this isn't the most exciting or the most interesting traversal in the world to just output what's in the array, but it is a starting point. Another example, a common task that we might want to do with our array is, what if we want to have the total of all the numbers in that? And then obviously if you have the total, you can do the average. So this kind of thing is pretty common. So we're going to start out with that idea of a for loop again. That's going to be a generic traversal. This time what we're going to do is we're going to add the fancy term for this is an accumulator. It just means it's a variable where we're going to add up all of the numbers. And so for that to work, we have to declare our accumulator before the loop starts. So I'm making a variable called sum. I'm setting it to 0. So before the loop starts, our total is 0. And then we're going to traverse the array. And at each element, we're going to look at what's in the array at that spot, and we're going to add it to sum. So it's going to start here, and it's going to say, okay, sum is equal to 0 plus 4. So sum is equal to 4. Then we're going to iterate, and it's going to say sum is equal to whatever it was before, which is 4. And we're going to add 6 to it. So now we're at 10. And then we're going to iterate, and it's going to add 2 more. We'll be at 12. Then it's going to iterate. We'll add 2 more, and we'll be at 19. So at the end of this for loop, sum is now equal to the total of all the numbers that it processed. And if you make a mistake on your length, you're either, if you go too far, you're going to crash. If you go too short, maybe you don't count all of the numbers. So that's where you start to get some of those, we call those bounds errors. The array, your loop goes out of bounds, or you stop short and don't go all the way to the boundary. But again, this is just a basic sum traversal. So again, there are obviously a lot more things you can do with arrays. There's a lot more to learn about them, but this is just a few minutes of talking through how they work and some ways you can visualize it and some simple things that you are going to need to do with arrays. So again, for more details, I'm going to refer you back to your textbook where there are plenty of examples.